Are you looking for a free CAD software for your DIY projects? Well, don't look any further. FreeCAD has got you covered. As the name suggests, FreeCAD is totally free of cost and an open source software. You will not have to sign up anywhere to download the software, and there is no subscription fee at all. Just like the old days, you install the software and you do whatever you want to do whenever you want to do. So let's get on freecad.org/downloads and download your version of FreeCAD 1.0 for your computer. It has Windows, Mac, Linux versions for you. After you install the software, I will walk you through what is FreeCAD and how you can build your first project in FreeCAD today. I plan to build this video and 2 additional videos for a new FreeCAD user who does not have any experience whatsoever in CADing. This video will address the interface of FreeCAD software and sketching. The second video, I will show how to build the 3D model, and on the third video, I will show you how to produce technical drawings out of this. So once you open up FreeCAD, you will see this start page. It is important that you know about few things before moving on from here. First of all, there is this button says don't show this start page again. You can select that and this page will not show up anymore. Before you do that, let's talk about these 5 options that we have. First of all, we have open file, the last one, not the first one. And if you wanted to open an existing file, FreeCAD, you can use this button, or you can do that from here, or you can just use the old shortcut Control O to do that. And here is this empty file, which opens up a new file, which you can do it from the file. Control N will do the same thing. So there is that. And BIM is for architecture, civil engineers, like whoever in the construction industry. And there is a dedicated workbench. Well, we'll talk more about workbench in a minute, but so there's the BIM. It opens up the draft and BIM right here. 2D drafting opens up the draft workbench right there. So that is the 2D drafting. So we don't intend to use these so many in our everyday life unless you are an architecture, then that's all you will be using, I guess. And then there is assembly workbench. This is the end of the process. You make 5 different parts and then you put them together. That's where this assembly comes up. So we don't foresee a day where you open up FreeCAD and then essentially this is the first button you click. I don't see that day coming up. So there is that. Parametric part is the default on this software where it opens up part design workbench. So whereas the new empty file would open up a part workbench, the parametric part will open up a part design workbench. Now I mentioned this workbench 4 or 5 times so far in the last minute or so. What is a workbench? If you are coming from SketchUp, Fusion 360, or any other softwares, they don't have any workbenches. Why do we have workbenches in FreeCAD? So before I get into that, I want you to go into preferences and then go to workbenches. Under the selector type, select tab bar. Once you do that, you will see these all the workbenches that came in default with your software line up just like mine. Otherwise you would have this combo box and then you'll have to drop down list, select one of them from the list. So there is that. Now that you have this same looking tab bar, consider those as different tabs, as you can see in Microsoft Word maybe, right? And there are like different group of tools tucked under a name of group, something like that. So workbench is a similar minded tools tucked under one name. For example, Part Design has a lot of tools that uses the software to build a part. Part Workbench has the similar like tools in there. So essentially, Part and Part Design can do the same thing, but in their own different ways. If you are a beginner, I recommend do not mix up between these two for now, unless you know what you are doing. In your software, the first installation, Part Design becomes the default workbench, and which is great. But if you wanted to change that, again, go to Preferences, and then in here it says Startup Workbench. You can change it to Part or whatever it is. So it is either Part or Part Design. My favorite is Part. So I have that as my default, but today I will be working on Part Design. And my intention is to work toward building this model. I downloaded this model from Google search, so it's not my product per se, but I'm just using that as an example for this. So this is the object that we want to draw, and looking from the top, the sketch is this one, which looks like a kind of curved slot with a pointy upper side. And in this technical drawing, we have some extra lines. These are coming from the difference in the plane. So this line right here, we won't be drawing that. We'll only be drawing these features looking from the top side. And to be able to easily draw that, I want to import this image in the background, and I'll make it cleaner. So what I want to do, I want to drag and drop it in the middle of the work center. And then I want to process that image just a little bit, because I have these dimensions on the other monitor set up. The distance between these 2 points should be 200. So now it says 100. Let's make that 200 and hit enter. So that calibrates the length, that scales the image up, right? And also let's make that 50 transparency and keep it on XY plane for now. And that's the end of image processing just for now. While drawing this sketch, I want to match it up with this model, but we don't know where this image is at as far as this three-dimensional space goes. So let's turn on the axis cross, which represents the center of the origin, like the center of the universe in this workspace. And looks like I want to set its center right here at this center point. I want to relocate the image. So right click on the image and hit transform and move it using these 3 arrows that we have. Scrolling up and down the mouse wheel makes it zoom in and zoom out. I think that's a good position to be. So let's take it out, and then that's the end of our usability for that axis cross. All right. So now we have the image in the background, and then we want to draw this sketch, right? The first thing first, I want to draw it up using, so we said we'll be using Part Design for this model. So there is a sketcher workbench, and then there is a new create sketch button in there too. But if you are using Part Design to build a model, use the Part Design sketching button. The same button but works just a little bit differently. So in the Part Design, the first task is to create a body, right? And then create a sketch within that body. So if you click on this button right now, it will create a sketch. It is asking which plane we want to draw it in. We want to keep it on XY plane from the top side. The XY plane, and hit OK. So now it's creating a sketch. You can see the sketch right here under the body. If you click on this button to collapse it, it will be hidden under that body right there. So this task panel will show us what's going on in the creation of this sketch. The first thing, I want to draw all the outlines. I'll be using all these buttons up here on the toolbar to create it. let's say this geometric edge between this point and this point is an arc, so we can go ahead and create an arc by 3 points. So 3 points is first point, like beginning and the end, and then give it a shape. So those are the 3 consecutive clicks gives us an arc, right? And then we can keep doing that. We can make another arc, but this time let's use the create an arc by center. So this is the center, and then we can do another 3 click, another arc right here. All right. And then there is this polyline. It also can be used to draw it. Look at, let's give it a try. So select polyline and select the end of it. So polyline is a little bit quirky. So now, because we are starting from the end of an arc, polyline by default is going tangential to that arc. So we come all the way from here, there, and then there is an arc in the way. So without clicking anywhere, take the mouse to the end of that arc that we want to draw, and then hit M, 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 one more time. There it is. So it switches through the different modes of polyline if you hit M on the keyboard. We want to draw another arc, and then by default, right after an arc, straight line goes tangential to that arc. Somewhere at this point, left click, and then go to the end of the line, and then hit M, M, M until it gives us the mode that we want. Right there. So right click to exit out of that command, and we got our outline. I want to make this 2 tangential too. Here the tangents is applied automatically. There are 2, but between this edge and this edge, let's make it a tangential. So we can take the tangency right here, click on it, and then apply tangency, or we can say T on the keyboard. Tangency brings up, or just select these 2 edges and hit T. So that's also 3 different ways to apply tangent. All right. So we have the outline. And I see there are 2 more circles right here in here, one in the center. So let's do those. Take the circle, or like keyboard shortcut GC, and draw this circle. I think I can apply this diameter constraint when I'm drawing it. I can see from the other monitor this radius is 25, the diameter. So let's go ahead and apply that. So now this circle is constrained, whereas this is not. Then let's draw this circle right there, and one more. So this is actually 10 diameter, so we apply that. And what we can do is, because these 2 are equal, we can say this is diameter 10. We can select the edge and then hit D on the keyboard. That brings up the dimension. So this is the smart dimension system. You apply smart dimension by hitting D on the keyboard, or like specific dimension from the list. So select the edge, hit D on the keyboard, and you can say this is 10 too, or we can take these 2 edges and make it equal. So that's also one way to constrain, which is actually a preferred way to apply constraint. If you have something equal to something else, apply it. Like these 2 should be equal. So E on the keyboard, that makes it equal. Let's draw this arc slot, which is a curved slot. So take that arc slot. To draw an arc slot, it's a big arc, like the radius is big. So let's take the center first and hit the first center of the arc, the second center, and now it's asking you to apply the radius, which is 7.5 millimeter radius on the end. Right. Okay, I think this arc is radius 200 millimeter, and then this one is 207. Looks way weird. Let's bring it down there. I think these 2 points are at the same point, so we can take these 2 centers and hit this constraint coincident button. It puts them together as well. So right there. And the distance between these 2 centers of this arc is 32. You just select the points and then hit D. That will give you the applicable dimension. So you can say this is 200 there. And I think this point is 40 millimeter above the origin. So when it comes to distance between a point and an origin, select the point. You don't have to select the origin. Select the point and then hit D on the keyboard. So moving the mouse up will give you horizontal, or the along, or the if you take it on the right, it will give you the vertical distance option. So 40 millimeter there. And then I know that these two are symmetric by the axis. So take these 2 points and then take the axis sequentially and then hit S on the keyboard. That makes it symmetric. Okay, what else? Oh, this center of this arc. So this is the arc. That's the center of that arc. That center is at the origin. So take these 2, hit coincident or C on the keyboard. And then this arc has a radius of 35. Make these 2 symmetric by the axis. S on the keyboard, and then the vertical distance between the origin and the center is 20. The horizontal distance between these 2 centers is 80. This is still moving, so we have to make these 2 centers symmetric by the axis S on the keyboard. And we have over constrained something, so let's take that out by Control Z and see what's going on. This is still moving. We wanted to apply symmetric, it is over constraining it. So we can do another thing. We can make these 2 points horizontal, and that's another way to actually apply symmetry, especially in the arc. So horizontal is H on the keyboard, or apply this button. Okay, now let's talk about some complex features, the inside ones. So this is almost a circle with an indentation inside, so slotted gap, and we can draw a circle of 50 millimeter diameter and then draw a slot between this point and point. Know that the end radius is 1.5, right? And then this axis point, we can trim it off by the trim tool. Take this. All right, select that line and select the axis. Hit D on the keyboard. That gives the option for angle is 22. And make these 2 lines parallel. P on the keyboard, right? I think somehow this radius is taken off. So radius is 1.5 there. So the length between this point and the center is 48. So select those 2 centers and hit D, and moving the mouse gives us the length, which is 48 there. Now it's still moving. So what I can do is take this 22 out, do it in a different way. I want to draw a construction line. So I want to draw a line that I won't be using to make any feature out of. So this is the line that goes through the centers, right? But I don't want it to show up in the final extrusion. So I want to make that a construction line. So select that line, and this is the button to toggle construction geometry, GN. So what it does is, when the sketch is finished, everything will show up except that construction line. So the construction line, it is there to use, but it doesn't show up. So taking that construction line, see if that helps. So I want to take this construction line and the axis, the horizontal axis, and apply the angle dimension with that. So now it's not moving up and down anymore. So that's another way to fix it. Right, but this point is still moving. What I want to do, take the construction line and one of the edges, make it parallel. So that makes it green, which means it's fully constrained, at least that part. I want to mirror it over on the other side. So take everything, double click on the edge. It adds anything connected. and also take this construction line and then move it over on the here. So that's mirroring it over. We have the mirror button here. It says symmetry, which is different than this symmetry. So this is constrained symmetric. This is symmetry. So what I want to do, I want to take all the edges and then hit symmetry and then select the symmetric. It didn't bring the construction geometry, so let's take that and then makes it take all of the and hit parallel P on the keyboard and then do the same. Just with the angle is 22. All right, and this length is equal to. So this is moving, and let's take these 2 points and hit C on the. That part is constant. We have 1 degrees of freedom left, which is this moving up and down. I know that this radius is 35. There. So that's a fully constrained sketch. We are almost there. So those holes are going all the way through, but it's not fully rectangular. There's some detailed instructions to it. So let's draw that. Comes in the inset. I have that in here. So we'll have to draw this rounded rectangle, but it's not rectangle. It's actually a trapezoid, rounded trapezoid. So let's draw that. I want to start off with a rounded rectangle, something like this. And then on the radius, I think it's 6 millimeter radius. So we got that. And now I want to take this horizontal and vertical constraints off. Let's delete all of those horizontal and vertical. Now it can be molded the way that we want. The distance between this edge and this center given as 13. So I selected this center and the whole edge. It gives us the normal direction. The normal distance is 13, right? And the distance between these two edges is, that's actually giving us angle. We want to say distance between this point and this edge is 15, right? And the angle between these two lines are 22, and the distance between this edge and the center of this big hole, take the point and the edge, the distance is 8. And while at 8, let's make these two parallel, right? And we are getting close. We have 2 degrees of freedom left. So this edge and this edge, they are parallel. Let's make this edge and the end edge, they are normal to each other. Right, there it is. It's a fully constrained sketch. So some of these we'll have to see which one applies. All right, let's take everything from this side and move it over on the other side by applying mirror right there. And it has 4 degrees of freedom left, which is, let's take these two edges, make them parallel, and then the distance between these two is millimeter. We just applied it, and the distance between the first edge and the center is 40. We take the center and the whole line, then that is 40, right? 1 degree of freedom left, which is, we want to make edge normal to the edge of the object there. So we got our first sketch completed. let's take a look at how it looks. Let's hide the image from the background, and that's our first sketch. Now that we have our first sketch, I want to stop it right there and then go to the next sketch, because I want to keep this whole video about sketching. So the part of the sketching is to rename it. That way we can come back and identify what we built. So this is the build that we did from XY plane. I renamed this as sketch XY. And in part design, it is meant for us to actually build on what we do. So everything will be within this first body. However, because the way I want to build this model, I want to build our next sketch in a different body. So what I want you to do is click on the new body, create another body, and then I want to start working on this one, on this another sketch that we will be drawing from the front. The same body, we will be drawing another sketch from the front. Because now we have two bodies, I'm going to go ahead and rename the first one as body from XY direction, right? And this will be body from XZ. It is very important to keep this separate for now. We will explain it in the next video why we did that. Now let's take a look at the model itself one more time. Now we build the XY thing. Now we want to build this XZ face. On the technical drawing, this is the XZ. So it's kind of like a wavy half S kind of thing, and this is symmetric by the Y axis, this vertical axis. So we can build only half of it and then mirror it over on the other side, like makes it easy on us. So that's what we will do. We will build this sketch on XZ and we will use this image in the background. So the image is there. All we have to do is move it on the XZ plane, right? And then you may have to adjust vertically to place it with this previous sketch. So previously we built this sketch at the bottom layer on the XY plane, and which is right there. So let's go ahead and place it right there, matching the bottom. Right. Now you can see that this sketch that we built is on the XY plane. It's at the bottom of this XZ plane that we want to build on. Okay, and then I will have these dimensions on my other monitor, but it will be available to you so you can follow through. I want to draw this sketch on. So draw a new sketch. Make sure this new body that we clicked, it's the bold one. Otherwise it won't work. So right click on it, make sure that it is active body, or like double click on it. And then draw a new sketch on XZ plane. That's where we are at. And I will make it quickly half of the model. So we will use the same knowledge that we learned from XY plane sketch. So I'll make it quick. I want to use the polyline and start from here. Take a straight horizontal line and make an arc by pressing MM, and take it down, meet on the horizontal line by pressing MM. So there, and then take it. So now it should be horizontal line, but it's not going, it's in the tangent. So I can make it horizontal, but I'll have to come back to apply the tangency. So I'll just leave it there and I'll come back to make it horizontal. Come about somewhere there, the vertical line, and then again horizontal on the right side, another arc in the middle. So M, 3 M's, straight connector, another arc. Oh, this arc is going to be in the other direction, right there, and then meet it with the vertical axis, and then come back to close it out right here. All right. So we know that we kind of messed it up somewhere here. Let's take care of those one by one. First of all, we make this one horizontal, and then now I can see that this point should have been on this axis. So let's take that and then take the axis, hit C on the keyboard. That's coincident. So that's matching. And then to begin with, I'm going to go ahead and make this one dimension D. So this is 32 on my plan. And then this point is, so because this is the distance between the origin and that point, we can only select that point and then hit D on the keyboard. It will give us the option for the vertical distance, which is 28. Then let's make this one horizontal. So take this line and hit H on the keyboard, and that makes it horizontal. Now let's talk about these arcs. The first arc that we have is dimension 19. And the second arc, that's dimension is 30 millimeter radius. This one is also 30 millimeter. So we can make these two equal. So take these two and hit E on the keyboard. That's equal. Okay. And then this top arc, this is radius 20. So we make that 20. Okay, we're going somewhere. And the point, this point is at 60 millimeter from this distance. So that's 32 millimeter right here. So what we can do, we can take this line and these lines and make them equal there. And this is still moving. And also this arc is, so there are 2 degrees of freedom right there. I have an angle between this edge and the horizontal axis, which is 40 degrees. We have 4 degrees of freedom left. Like this 40 degrees, this will be also 40 degrees. So we can apply another angle dimension, or we can take these two and make them parallel. Takes care of it. And now the center of this arc, the apex of this arc is on the same vertical plane as this meeting point at the horizontal. Let's get that apex. I will use 2 construction geometries. The first line will be horizontal line coming from the left end of the curve, and there it makes it over constrained, so we'll come back to it, or we can just take care of it right now. Select the redundant constraint and hit delete. Do the same for the other end of the arc, but this one is not going to be horizontal, so we take the tangency T on the keyboard and apply tangency between the arc and the line. Now this apex, this meeting point, take this point with this horizontal meeting point on the horizontal arc and make them vertical, B on the keyboard. So that kind of places them at the same vertical plane. So we have 2 degrees of freedom left, and which are the length of this whole object. And we can take help from the previous sketch that we built, or we can just calculate those. So I would like to keep them independent as much as we can. So what I'm going to do is I'm going to apply the distance. So this point is at 69 millimeter from the origin, and then the radius of this outside arc was 35. So this point stands at 100 millimeter plus 35 millimeter from the left of the origin there. So that is our completely fully constrained sketch. And what we can do now, we can take the whole thing and mirror it over on the other side, or we can do it after the extrusion, which we will do it in the next video. So these are the 2 main sketches that we will need to build this model, and there will be some other fine-tuning afterwards, because there are some groups and there are some holes, and that we will do it on the 3rd. But today I want to close it out right this moment, where we have one sketch from XY plane and another sketch from XZ plane, and in the next video we will learn how to combine these two to make the mold of the object that we are working towards. I hope this detailed video helped you learn sketching, constraints, the sketching tools, and definitely about the planes of 3D objects. If you have any question, comment, suggestion on this video, please let me know in the comment section below, and I hope to see you in the next video in this series. Thank you for watching.